dark shadows on the rocks. Three dark shadows, shaken, not stirred.
Everybody, Lisa, everybody. As we just said, my name is Tomas. I work here. I'm assistant professor here. If you saw the poster that said associate professor, I really appreciate the sentiment behind it, but I'm not. I'm assistant.
You can change it now.
And I work here, and like Felipe, which is, I don't know, this is the first time I see a place or an event where the two closing talks are from two people from Uruguay, which I don't know what it means, but they mean something. But yeah, well, so I am from Uruguay originally. I've been here for a few years. I know everybody knows it because everybody been to school, but in case you don't remember, it's that little country there in the south of South America. And I didn't like living in a small country, so I moved to Hong Kong. This is Hong Kong and Uruguay compared. So Uruguay is 160 times larger than Hong Kong, but we are only 3 million people, so it's a difference in density. And I mentioned that, I'm not entirely sure why, but one of the reasons is because I am very interested in the representation of data. As part of my work, I try to explore how data is represented and what information the choice of that representation codifies. I starting from the idea, like Paul Ricord said, like every praxis codifies a worldview, an understanding of the world. Then I try to explore, well, what are the understandings of the world that are present or that show up when we choose one way to represent data or another way to do it. In general, I'm interested in aesthetics, politics, and philosophy, and I explore that through art, in particular through new media art, which I consider, what I think of new media art as the art that becomes possible when the artist appropriates the knowledge behind a certain technology or a certain scientific practice. We can also expand that idea and think that new media art is the art that is only possible when that happens, but also the art that is only possible when artists appropriate the processes behind the creation of new knowledge. And that's where I try to center my work. The idea of what art is only possible when us as artists try to understand but also appropriate the knowledge and the processes of creation of new knowledge. But when you do it through art has certain specific qualities that starts from an aesthetic preoccupation, an aesthetic interest. So it's not only the creation of new knowledge, but it's the creation of new knowledge that is explored through a certain aesthetic axis. So I'm going to show a couple of my works very fast, just to contextualize the type of things that I do, and then I'm going to move on to the main topic of the talk, which is, as the introduction said, artificial intelligence and the social impact that this technology has. So this is one piece I worked a few years ago that I did in New York, and I started being interested in the electrical stimulation of muscles. So this is one of the first, I don't know if we have sound. I think the sound is coming from my computer. I don't know if let's see here.
Sí.
Yeah, very good. So this is one of the first tests I did in New York, which if you see, when I press enter on my computer, my hand starts to shake. What I'm doing is I'm simulating the ulnar nerve on my hand and making it twitch. The first idea I had behind this was to create, to explore the aesthetics of errors, of glitches. So one of the things I did was I asked my wife, who's a painter, to draw something while I electrocute her.
That's rarísimo.
She's trying to draw a cat. So this shows two things. The first is I have a very, very patient wife. And the second is that she laughed. I don't know if you noticed, you heard that. And this is something very interesting because I've tried this with a lot of people. And women laugh and men freak out. And I don't have an explanation for that. It's just something that I saw happen over time and time over. So there's probably some different relationship with the body or with control, or I don't really know. So these were the first experiments, and I used that because when I did that work, it's when the migrant crisis started to be part of the news. And I was very interested in the relationship that societies have with economic migrants. Economic migrants are an important part of society. They fulfill a needed role in society, but at the same time, they are discriminated against. They are objectified. They are the other, those others that are not us, that come and somehow exploit our wealth. So this is a photo of people trying to get to Europe from Africa through the Mediterranean Sea. And I found a database that collects or that stores or that represents the deaths of people that died trying to get to Europe from Africa. So I took that database, I took 1 year, and it was 5,500 people that died doing that. And what I did, I mapped the corresponding day and the number of people that died into that specific day to the time of a performance of Beethoven's Sonata Pathétique. So if somebody died half 6 months into the year, that would correspond to half the time of the performance. And then what I did is I had a piano player play that, and I will affect his playing with electrical muscle simulation, representing the number of people that died on the day corresponding to the time into the performance. So it's using a classical piece of European culture to represent as a kind of like an embodied data visualization, as a representation of these people who try to get to Europe. So this is one of the first experiments with the piano player. But I discovered that I like to electrocute people.
Está buenísimo. Esto tiene que ser.
So this is an extremely good piano player. Has graduated from the École Normale Supérieure in Paris. And then we did a show with the actual performance. That was not controlled by me, but it was controlled by software I wrote. Here we can see a visualization. It's a timeline, and then the spikes represent the intensity, which corresponds to the number of people that died on that day. I'm only going to mention two pieces, and very fast. This is an artwork I just finished in a collaboration with the girl that is in the middle, from UC Davis in California. And what we did, trying to explore, from an artistic point of view, trying to explore the social impact of artificial intelligence, which is what I want to talk about today. What I did is I created this is my software, there's 3 screen captures for my software. And what I did, I created a racist door. So it is a door that is locked if you're not white. So now she's being detected as non-white, and it's locked. The video is ridiculous because it could be fake, but there is a camera and it works. And this is me open. It's also a door that has no purpose because it's not part of a wall, so you can actually walk around it. So what we're gonna be showing it in a couple of places in coming months. So if you're in Tempe, Arizona, you can come and see our racist door, or in San Francisco, California. But yeah, okay. I could talk forever about my work, but I will not. what we want to talk about is artificial intelligence, and this is the topic of the talk. And artificial intelligence understood as these technologies that are appearing more and more in our everyday life, but also artificial intelligence and social issues, which is I want to explore the impact that these technologies are having, and especially will have in our everyday life. So the plan for the talk is to talk a little bit about the hype, then to talk about the technology, then to talk about the impact of that technology, and then the end. So first, the hype. Why I want to talk about the hype? Well, because we all listen and hear and see a lot of people saying a lot of things about artificial intelligence. And there's something that I'm interested in exploring and discussing with you guys, which is what is the actual impact that these technologies may have. There are two different possible understandings of the situation we are in. One is, all right, reality is political, not technological. It doesn't really matter what technologies we bring into being, because what actually has an impact on how society functions are the social structures, the structures of systematic inequality, of division of wealth, capitalism, and so on, and not the specific implementation of those social structures or social policies with this or that technology. On the other hand, there is another possible point of view, which I think both are actually compatible, which is AI is the new electricity. And that's a quote by Andrew Ng, who's now a professor at Stanford, but also he was the chief of AI at Alibaba and Baidu. And so he's one of the most famous researchers in AI. And he has this idea of AI is the new electricity, in the sense that when electricity appeared, it changed everything. Every single activity, human activity, that had been performed for hundreds of years in a certain way, with the introduction of electricity, changed. If there was no area of human activity that was not affected by the introduction of electricity. And Andrew says, all right, this is the same situation. There's nothing that is going to be the same after the introduction of artificial intelligence. There seems to be a certain consensus in the world about the importance of AI. We can see in the media, here is the Wall Street Journal saying how artificial intelligence will change everything. The billionaire Mark Cuban said, like, I think artificial intelligence is going to change everything, like 180 degrees. This is from Huawei presentation a few months ago, saying that AI has become an unstoppable force that will transform everything. Also in the arts, Ars Electronica last year, or the year before, I don't remember, the main, the theme of Ars Electronica, which is the most important new media art show in the world, was artificial intelligence. And this sentence that this sentence that I really like, the other eye, which is this idea of intelligence not being the purely or uniquely human characteristic, which is, I think, something worth reflecting upon. Or Elon Musk saying that AI is far more dangerous than nuclear bombs. But at the same time, there is another, as I said before, another way of seeing the situation, which is reality is political, everyday life, society is political, not purely technological. There are no technological solutions to political problems. And I want to focus on this. I want to focus on the hype. I want to talk for a second on the things that some of the people that say that AI is going to change everything put forward as examples, as if those examples are very true. For example, it's been said over and over again that the political landscape has changed in an unprecedented way by the introduction of digital technologies, and in particular AI, by the introduction of software that can work with data. And examples for like this are
It got me
shown all the
thinking
time,
about my full-time
which is
employees.
this a fake
Their ability
Obama.
to survive on $8 an hour in New York City. And foremost in all of our minds has been the loss and the grief felt by the people of Orlando. Most of us don't get our healthcare through the marketplace.
Which is a synthesized footage. So they say like the narrative goes like, okay, now we cannot trust the media, we cannot trust the images that are put forward because they could be fake, as this one here. But also, because of that, the impact that technology has in political campaigns or in the political discourse is very new. However, there are millions of examples of new technologies having an unprecedented impact on the political narrative and on the political campaigns that every single time has been touted, okay, this is new, this is something that we have not seen before. So this is a very famous debate between JFK and Nixon, which was the first time that a debate was shown massively in the US, and that it actually changed the outcome of the elections in the US. Nixon was the favorite. JFK was a very young senator, newcomer with no hopes. In this debate, which is the first time that the majority of US households had a TV, and this debate, Nixon was coming out from a flu, and the clothes were not tailored, so he looked sick and weak. And Jeff Kennedy was cute and confident, and it actually changed. But it's the first time that massively the image of the politicians was experienced in a more or less direct way by the people who voted. So the same narrative, oh, this is new technology has changed everything, was heard when the TV was introduced into the political landscape. The same narrative was also when Obama won, which was the first politician, JFK was the first politician to take advantage of the television. Obama was the first politician able to take advantage of the internet. So the process of fundraising and the processes of communicating with the voters changed radically after Obama's first winning of the presidency. It was the first time that the number of people who were contributing to the campaign was increased tenfold because they were contacted through the internet, and also this sensation of intimacy of a politician responding directly to the needs of the people who vote, that this more or less direct communication internet provided was also new. So I have here a lot of text that I don't care, but it's just he's about Obama. Is that he has run the campaign where he's using very modern tools, spoke to a new coalition, talked about new issues, and on the way he's reinvented the way campaigns are run. So this, again, the same narrative of this technology changes the political landscape or changes the social landscape. We've heard it more than just now, a lot of times. But other people say, okay, well, but AI creates fake news, and this is new. This changes everything. There are a lot of examples of fake news that as old as news are. This is from the mid-1700s, where thanks to the introduction of a new technology, the press, there was a massive campaign of misinformation or disinformation, where, for example, they said that King George II was ill and about to die and unfit for government. Or we could see the manipulation of images. This is Stalin here, and this is Nikolai Ivanovich Yezhov, who was the head of the intelligence, and then he was removed from there. But okay, we all know the examples of Stalinism. This is one of the most iconic and famous portraits of US President Abraham Lincoln, which actually was not his body. It was the body of Southern politician John Calhoun. Or the most famous photo of General Ulysses Grant, which was actually the combination of 3 photos. So it was. So again, this narrative of everything is new, actually, it does not seem to be as true as some people say. The examples of misinformation, disinformation, or people falling for things that technology allows are plentiful in history. One that you probably are acquainted with is the World of the Wars of Orson Welles. In, I think it was I forgot the year. But this is very interesting because it was, so the radio was introduced as a novelty and had no relationship with news. The first time that radio was started to be used by people as a reliable source of news was with the World, because it introduced the concept of the world correspondent that was sending real-time information. This idea of the necessity of real-time information was not present in society. People said, all right, I'm okay with getting information once a week or once a day in the form of a newspaper. The war increased the pace of news and introduced the concept of the radio as an important source of news. In that context, when the radio was a source of news, but at the same time was a new medium, is when Orson Welles broadcasted the World of the Wars. And as everybody knows, it caused a mass hysteria, a lot of people that believed. Now there's something interesting. How big that reaction was. And there's a lot of people who say, researchers who say that actually it was like only a handful of people that believed it, but the newspapers wanted to discredit the radio as a trustworthy source of news, so they ran a fake news campaign about the fake news of the World of the Wars, trying to convince people that no, you cannot trust the radio. So it's a combination of it not being as bad as we think it was, while at the same time a lot of people believed it. You can say, all right, but that's because the radio was new. That will never happen now. It's impossible for it to happen again. In 1968, in Buffalo, they ran the same thing again, but they also ran an advertising campaign before, trying to make sure that everybody knew that it was not true, and yet a lot of people believed it, and actually there were Canadian military going to the US trying to help against the war, with the war against the Martians. So again, the impact of technology, this does not seem to be that related with how new it is, and it seems to be something that taps directly into certain characteristics of us. That was also not only in the US. In 1949, that was done in Quito, Ecuador, and there was a massive hysteria. People were rushing out of Quito, trying to escape the Martians. The military, all of them believed it, so the whole army of Ecuador went to Quito to defend it against the Martians. Imagine that if you're in doubting if it's true or not, and you get out of your house and you see all the military coming, so everybody was convinced. When the radio players saw the impact, they issued an apology, say like, hey, no, this is not true. And so the terror turned into fury, and they went back to the radio and set it on fire, and 10 people died. So it is not only American, and also the impact that technology has in creating the narrative is extremely, extremely high. There's also this narrative of AI is the future. AI is going to change the way we do things. And I would say, all right, that may be true, but technology, we have the technology to have cars that don't pollute, yet we use cars that pollute. We have the technology to use renewable energies, or we have the technology not to use child labor, and yet there are 260 million children that are employed around the world according to the International Labour Organization. Therefore, it seems to sustain the narrative that problems seems to be structural, social, and not technological, or not purely technological. Even in high-tech companies, they are being sued by because of they use child labor. So when we think about the future of technological production, we see these images and we don't see these that seem to be as likely to happen, or to at least to coexist in the immediate future. They also say AI is new media, and as we saw, the introduction of new technology has always had this impact of changing the landscape, and yet leaving the landscape more or less untouched in terms of social structures or social processes. So why do they say that it's a new electricity? Is it because you can put Nicolas Cage face on everything? It does not look like the most earth-breaking thing, or that you can create porn. You can, which is the deep fakes, which is a major thing that people create porn films, putting the face of one person into the face of the porn actress. I still think that putting Nicolas Cage everywhere is a reasonable activity.
Master, I won't let you move the matter. I will take this to the Federation Council. I'm acting on orders from the Federation Council. How can there be an order to abandon the Prime Directive? Prime Directive doesn't apply. These people are not indigenous to this planet. They were never meant to be immortal.
But
You're looking well, Jean.
But one can also think, okay, if deep fakes are a threat to democracy, are a threat to these political campaigns, then why it was not such a big issue when access to those technologies that allow you to create fake news, it was restricted to only the rich. So perhaps one first hypothesis will be, okay, this is interesting not because of the end results, but it's interesting because it somehow democratizes the fake news, somehow puts the ability of manipulating a little bit the social narrative in the hands of more people. So, what is AI? Let's talk a little bit about the technology. So, AI or machine learning can be used, for example, to create fake faces, right? To create fake news or to create data that doesn't exist. So I'm going to ask you, which of these images is real and which is created by a machine learning, artificial intelligence software? Any guesses? Both are fakes. That's why you need to study perspective, because you can tell like this. So both, these are not two existing people. These are automatically generated or inferred from training data faces. But again, the ability to manipulate photos, as we've seen, is as old as photography itself. So this does not change the landscape. So what does it change? Well, what changes is, and I'm going to come back to this idea over and over again, what changes is that up until now, we didn't think that computers alone could do that. It required, up until now, we thought, okay, creating believable fake images is totally doable, but it requires a high commitment of human labor. For the first time, we say, oh, we can do something that is as believable as the fake images that we had before, with more or less no human involvement. I have a little video here from NVIDIA from a few months ago that shows these generated images. So I don't know if you see what is the idea. From the photo on top, they extract the gender, the age, the hair length, the glasses, and the pose, and everything else from this image. So with this gender, age, hair length, glasses, and pose, and this face, you get this. From combining this gender, age, hair length, glasses, and pose, and this face, you get this, and so on and so forth. So now they change again, the magic is not being able to do that. The magic is that is done through a more or less automated process. So this process that we just saw here is AI, is artificial intelligence, but it does not really look like the things that we would think. It is artificial intelligence, but it's not what we would think that artificial intelligence is, like these new beings that will conquer the world like Robocop, or that will solve incredible problems. If you search for artificial intelligence in Google Images, as of yesterday, you get in Hong Kong, you get these results, and this does not really look like that. It's like these robots that change everything, or that are as smart as us, or there seems to be a distance. So what is this new electricity that Andrew talks about? And the key factor is that our intuition of what can be done with computers was wrong. And what do you mean? What happens? What happens is, like, we thought that in order for a problem to be solvable with computers, we had to understand it from a formal point of view. We needed a formal model of the problem with which we create an algorithm that operates on that domain, that works on that problem. So we have an explicit modeling. And that restricted the areas where we could apply computers to, because the areas that we did not know how to model were, by definition, not able to be attacked by computers. All right? However, the AI revolution, or the machine learning revolution, exists through what I call implicit modeling, which is, all right, you always need, for a computer to work on something, you always need a model of the problem. But instead of doing it explicitly, you do it implicitly. You just feed to the machine learning software a high number of examples, let you train that machine learning process, that computer, that software, through these examples, and the software itself implicitly models the problem. And that expands the areas where you can work with computers, because you escape the problem of you formally modeling the problem, or you formally having to understand from a formal point of view what the problem is. And that changes everything, in the sense that it expands radically where you can use computers, where you can apply computing power to. That also means that now this artificial intelligence, this umbrella term, actually now means machine learning, because this machine learning is this process of machine learning. Actually, is a lot of things, but basically machine learning is this idea where there's software that learns from examples, that you provide a lot of examples, and then the software goes through this implicit modeling process. There are a lot of different flavors of artificial intelligence. Up until 10, 12 years ago, we all knew that machine learning didn't work, that artificial intelligence didn't work in all of its flavors. It would work for very, very, very simple, this is from Wikipedia, this table. It would work in very, very specific problems, but it would not work as a general solution to things to be solved by computers. This is not a new concept. Machine learning was coined by Arthur Samuel in 1959 at IBM. By the way, I learned today that in the US, IBM is the company that has the most patents every year from 2018 till 1992, which is quite impressive. And they also in 1959 coined the concept, the idea of machine learning. And machine learning is, as we said, the construction of algorithms that can learn from and make predictions on data. These algorithms overcome the idea of following pre-decided, pre-coded, predefined behaviors and can learn the desired behavior from the training data. So why is it successful and it was not successful in 1959? It's not because there was a qualitative change on our understanding. It's because now we have computers that can train models that are more complex. So it's because we have more computing power and because we have more training data. Because of the internet, we have this concept of big data. We have a lot of examples of things, and therefore we can combine a lot of examples and a lot of computing power, and that actually made something that we knew that didn't work, which was machine learning, turned it into something that now works for a lot of new domains. So what machine learning is mostly uses neural networks. I'm going to explain very briefly what a neural network is. And basically, a neural network is a network of neurons. A neuron is not really a neuron, it's just that as a metaphor because it's inspired by biology, but has nothing to do with neurons, with real biological neurons. What it is a function that gets some parameters, like any function, and gives some result, right? So we can combine these functions so that they get some data, that input data, they process that data, then they give some result to some other neuron that combines the results of the previous neurons, the previous layers, and then keeps processing, right? What is the magic behind here? The magic is that all these functions have some parameters that are not the input, but that they are inside, that we can tweak so that we get the result that we want. So what we do is, we have the input here, we have the output here, we have some parameters inside, and we just start giving examples and using those examples to automatically change the values of these internal parameters. So we give one example, we change the values so that we get a result a little better. We give another example, by we I mean the training process that is automatic. Changes the values. We give another example, change the values. At one point, after many examples, the whole network learns how to give the results that we want. For the cases that we use in the training, but also for other cases that were not part of the training corpus, but fall within the same problem domain. Does that make sense? So why we talk about deep learning? Well, deep, the only thing that deep means is that there are a lot of layers of neurons. So we have the input here, and that goes to a second layer, that goes to a third layer, the fourth layer. Deep, the only thing that deep means is that a lot of layers, right? So for example, if we want to classify an image and say the most basic problem of computer vision, is this a cat? What we do is, okay, we have one neuron per pixel of the input image. So one pixel is going to come here, another pixel is going to come here, and then we give it a photo of a cat and tell the neural network, hey, this is a cat. So the neural network, the learning process, adjusts the weights of the hidden layers, the layers inside, a little bit. We give it another photo. This is also a cat. So it changes the values a little bit through something called gradient descent, which is, it doesn't matter what it is, but it's just going to the optimal point. So remember that these are functions. So what it does is it moves the results through the possible values till it gets to the point where we want to be, the maximum likelihood of being able to tell if it's a cat or not. So we train, just give it literally hundreds of thousands, millions of examples, and after that, after all this, the weights of the layers here are trained, are specified by this showing of examples. Now we have a network that we can give it a new example, a new image, and it will tell us if it's a cat or not. Right? And that's the only thing. The magic is that as long as we have a digital representation and an idea of what the desired result is, we can apply the same technique to tell if an image is a cat or not, or to tell if an instrument is this or that, or to tell, basically to discriminate between things being of one kind or other kind. There are different machine learning architectures. These are the most famous: convolutional neural networks, recurrent, long terms of memory, and GANs, generative adversarial. What they do is they just make, for example, the information not only go forward, but for example, go a little bit backwards, and so they can remember, or neurons that are further ahead on the network can affect neurons that are behind, and that allows it to, for example, to remember more things. Or convolutional, which they take, some neurons take up a little portion of the image instead of taking looking at all of it or looking at one pixel, and that allows it to learn structures, so that's easier to tell. Convolutionals are used in images a lot, so they are very good at telling you if things are cats or not. And one of the most fun ones are one introduction by Ian Goldfellow from Google, which are the GANs. And the GANs are, all right, they try to solve the problem of you really need a lot of examples to train a network. So one way around it would be, okay, let's train two networks. One network that is the discriminator, tell us if this is a cat or not, and the other network is the generator. It generates data and tries to fool the first one. So you have two networks that fight, and they get better. The creator gets better into fooling the discriminator, and the discriminator gets better into telling if the image is a cat or not. So you have them fight all the time, and they train each other, right? And they can be used for a lot of things. For example, to create new versions of photos, because if you have you train this image that generates false images to fool the discriminator, then you can just use that to generate things for example, to put Nicolas Cage faces on things, or to generate rooms, or, for example, you can take the representation you can do arithmetical representations, which is quite magic. You can take a network that represents man with glasses. You can subtract the values of man without glasses, another network. Remember that a network is a collection of the weights that affect the neurons inside. So you take the weights of a network that generates man with glasses. You subtract the weights of a network that generates man without glasses, and you add the weights of a network that generates woman with glasses and without glasses, and you get woman with glasses. So you can do, because you train those networks into generate images that will try to fool the discriminator, you can do math arithmetic with those generators and expand the universe of the things that you can generate or represent or predict with the network. So the third thing I wanted to talk about was the impact. Why these techniques of telling if one thing is a cat or not, or these techniques of generating Nicolas Cage faces have a strong and a relevant impact on life. I'm going to give a couple of examples of things that now can be tackled with computers, and before they were impossible for us to tackle with computers, and the things that we can do now with computers and the impact that may or may not have. For example, there is now an artificial intelligence judge developed which can predict court verdicts with 79% accuracy in the US. So a problem that seems impossibly hard to tackle from a formal point of view. How do I go about to write a software that can predict the result of a legal case? Okay, normally before we would say like, oh, first we need to understand what, we need to have a formal model of legal cases. We need to introduce into our model how people react to things. We need to introduce a lot of information from society, from mankind itself. What does it mean to be in favor of something or be against something? With this technique, we just have a neural network. We feed it hundreds of thousands, millions of legal cases, and then it trains the weights, and then it can predict with a high, way above a random prediction, it can predict the result of something that seems to be intrinsically human. And this is the key thing. Things that we think are intrinsically human, that represent some inner quality of or characteristic of what being a human is, can actually be represented by brute force statistics. We give enough data, and then we have an implicit model of those things that are so hard to describe. So you say, all right, but this is kind of like a university exercise. Now we can predict. Well, what's happening is that now AI are doing a lot of legal work. For example, the summarizing of cases is done by automated process in a way that is indistinguishable from the summarizing that people do. You say, all right, that helps. It's a tool to help for lawyers to do their work, but it's not that important. For example, Frank Levy from MIT said, like, okay, this is a popular view that if you can automate one piece, you're going to automate everything, but that's not the case. And even though if the results are indistinguishable from a memo written by a lawyer, in this case it's just a tool that helps and the whole process remains unchanged. There are, in the US, which is a good example of everything good and bad in the world, they are using software that helps the judges specify a sentence to a criminal, or somebody who's deemed a criminal, and actually the sentences that the software suggests are most of the time used directly as the punishment for the criminal. So the software now is deciding what the punishment to a convicted criminal is. Or if you want to go, if you are eligible for parole, so you can get out of jail if you're an inmate, they use software that predicts how likely it is for you to commit a crime again and grant you parole or don't grant you parole depending on the results of that software. So it's a very dystopic scenario. Why is it dystopic? Because we don't trust this algorithm, because these algorithms are trained with data, and that data codifies structural inequalities. So, for example, those algorithms are intrinsically racist because the data that they're trained with is racist because society is racist, and therefore they continue these structures of structural systematic inequality. But again, new electricity, things that seem to be absolutely impossible to do with computers, now not only they can theoretically be done with computers, they're actually being done with computers in real life, affecting people. There is a software called Compass, that is a software that is used in the US. That also is incredibly weird because it's protected by copyright law. So if you're sentenced by Compass to jail, you don't have the right to take a look into how it works, because that's copyright of the owners of the software. So you're sentenced to jail by a black box that you don't have the right to peek into to protect the source of money making of this company, which is really, really perverse. And it's also very similar to science fiction, as you may or may not remember from the telly. This is true, by the way, which is, I would not believe me if it was not that I did the research. So here you can go to this Wisconsin Department of Corrections, and you see they use the Compass assessment tool. And you can go to the Compass website, and they have an FAQ, frequently asked questions about the use. where it's so absurd, so obscene. They say, for example, does your tool require an interview with the inmate? And they say, well, no. If you have more data, better. But if you have a little bit of data, we're still going to give you an answer. Just kind of like a very weird way to see things. And again, it's because there is what is upsetting is this objectification, this otherness of the inmates, of the people who are data to these processes, which is what I wanted to reflect on the piano piece, on this idea of, okay, let's try and bring this otherness, these immigrants, into a embodied representation as a way to bring it into our intimate understanding of what is us and what is human and what is important. It's been there's a lot of analysis of Compass, ProPublica, which, if you don't know, it's a non-governmental NGO in the US, which is very, very good. I highly recommend that you go and read their reports. And they find that these things are horrible, as one would suspect. For example, black defendants were often predicted to have a higher risk of recidivism than they were actually were. White defendants were often predicted to be less risky than they were, and so on and so forth. This I found when I was doing the research for this subject. I found this, which is the most heartbreaking thing ever, which is a woman named Mary that is saying that her son received a letter from the DA office to have, the DA is the prosecutor, right? To have Compass assessment done, and then she says that where is it? Oh yeah, and then she's asking in a forum called Family Schizophrenia, because her son is a schizophrenic, and she's feeling understandably worried that this software will not be able to accommodate the characteristics of her son, which is a reasonable worry. However, there are good things that can be done with this expansion of what is doable with computers. For example, in the healthcare, now we have systems that can tell you if you have cancer or not. Or, for example, you can find swing justices. You can process this data and then find which justices, which are like super judges in the US, are more likely to change opinion on a certain subject or on which subject. So you can use these same tools to hold accountable people who are in positions of power. That means I don't want to paint the bleak image of everything AI is horrible. What I want to paint is everything is horrible and AI goes into that universe. There are a lot of startups in law that using this. Of course, the legal system is just one example. I agree with this idea of new electricity, this idea of implicit modeling, changing everything that we can do as human. Because there is a major policy called that word change, thanks to not having to explicitly model a problem. For example, how AI, as I said, is a horrible way to talk about machine learning, which is more humble and more real. How AI can help diagnose mental disorders. Or, for example, this, which is quite incredible, which is a software that coaches call center workers. So it's a software that helps humans to be more humane when they are being rude or not sensitive enough to the callers. The software helps train them, which again, it's mind-blowing, because the things that are so incredibly human, so out of the reach of computers as up until 4 or 5 years ago, now are just commercial uses of the software. And so on. So I can put this online, these slides. I mean, because I see a number of people taking photos. It can be accessible at Linda's website. So there is something strange here, which is, all right, we have had a software, an algorithm, a technique that its use was to tell if something was a cat or not, and all of a sudden the places where we can apply that technique seems to have been exploded. which is weird because it seems like what is being represented it was also our intuition of what can be represented was wrong. Our intuition of what can be done was wrong. Early examples of classification, because as I said, a neural network basically is a classifier. It tells you this is a cat, this is not a cat. Early examples and successful examples of machine learning was, for example, when you, customers who bought this item also bought this other one, which is the same data, the same idea. I give you the input data, all these customers did this buying, and now I have the output, the prediction, the classification. Oh, this thing is more or less likely to be also bought. Or if you use Spotify or any of these music software or services, they're the same idea. They train by the likes and dislikes of thousands, millions of people, and then they're able to predict the likes and dislikes of millions of people. So we can ask ourselves, what is classification? What can be predicted? Where we can take this idea, this technique of training with a lot of examples and then getting results. And the things that we can do were very, very, very unexpected. For example, we can train with pictorial styles and then transfer those styles into other images. Why? Well, because if we have all these layers that have been trained, we can, and these convolutional neural networks that I was mentioning before, we can identify one layer that represents a certain statistical information from the input. For example, we found that there were going to be some layers that would represent the brush strokes on a painting. So now, after we identify that, we can cut them and paste them onto a different network and transfer that statistical representation, the brush strokes, into a new image. So we can, for example, take the Mona Lisa and represent it as a Van Gogh, as a Monet, or as a Picasso. Just because we've learned through the same idea of feeding data, a statistical representation, in this case of a style, which again seems to be way off for a computer to handle. Now we can use it and we can generate things. And people generate weird things. For example, they can transfer the style of a city into a different city. Or they can generate new things. Or they can... this is something, if we have time I'll come back to it. Or they can generate new synthetic images. For example, now, one thing that I was reading the other day is they take all video games and they increase the resolution, because they have a neural network that takes all the textures and generates new textures that have the same semantic information, but they look with like a high resolution to us. We can, of course, generate creepy things by exploring what is called the latent space, like the spaces in between the 2 points that are generated by those GAN generators that I mentioned. And we can get the Michael Jackson's, if you're my age, you will remember Michael Jackson's video clip, black or white, that had this. Now it can be done with a computer and not by a team of researchers. One thing that really caught the imagination of people was what's called deep dream. And the idea is, okay, if we have if I have an image that can tell me if something is a cat or not, I can go the other way and generate synthetic data that maximizes the possibility of this network telling me that it's a cat, right? I can just create fake data that makes the network say, yeah, this is a cat. That means that I can also take an existing image, like this photo of me when I was young, and start tweaking it so that it makes the network believe that there are things. For example, if this network knows how to predict, how to classify eyes, so it starts hallucinating eyes everywhere. But this is not. It looks super metaphysical, but actually the only thing we did is we take the photo and change the value of the pixels so that we maximize the likelihood of the output of the image being something of the neural network being something that it's been trained to recognize. This, of course, if we think about the social impact, we need to think about how these things can be used. And one thing that has changed, and this is a sentence that I really like, a quote by Jim Cogan. He said that in a conference that Hector and I organized a few months ago, in April. And it was, okay, now things have changed, because before we needed explicit modeling. The investment was on people who could do that modeling. Now the modeling is implicit, so code is cheap and data is expensive. Now we need to get the data that will allow us to infer these models. Which is also a way to think like data is the new oil. It's the new source of wealth or the new source of power. Because as we said before, machine learning algorithms learn the behavior from the data and therefore are also a little bit controllable by the selection of the data sets. Because, as we said, they have statistical modeling and statistical representation and an implicit modeling. This, of course, does not mean that they are sources of ground truth. They are not perfect. The only thing they can do is to infer a model from the training data. So this is an example of breaking the classifiers. They have an image that is being classified as a panda with 60% of confidence, and then we add some noise, some specific noise, and then now it classifies a completely different thing, right? So we could have like a CAPTCHA that will detect only let robots pass and not humans pass, right? Because these images, some of them are classified as spiders by the neural network, but for us, because those neural networks are not representations of data, of reality, they're just being trained so that to maximize the likelihood of a certain result. In this case, some of these are classified as spiders, some are not, and for us it's impossible. And this shows something that I think is very interesting, which is this blending, this new situation where the things that can be done by computers and by people seems to be all confused and blurred. For example, this person bought a car and they had it tick on the form by hand that she was not a robot, which seems very ridiculous, but it shows this mixing. There's this short video that I enjoy a lot.
Everything is too fast now and totally unreasonable. The world is run by computers. The world's run by robots, and we spend most of our day telling them that we're not a robot, just to log on and look at our own stuff. All day long. May I see my stuff, please? I smell a robot. Prove to me you're not a robot. Look at these curvy letters. Much curvier than most letters, wouldn't you say? No robot could ever read these. You look mortal if ye be. You look. And then you type what you think you see. Is it an E? Or is it a 3? That's up to ye. The passwords have passed. You've correctly guessed. But now it's time for the robot test. I've devised a question no robot could ever answer. Which of these pictures does not have a stop sign in it? Fucking what?
John Mulaney is very funny, but also it shows. What's that? Is me or is that beep? I don't know.
Robot.
It's the robots uprising. It shows this blurring, this confusing situation where we don't know what things can be done by computers or that require human cognition, human labor. And one thing that happens with this process, through this process of training automated algorithms through data is the idea of an emergence. An emergence, not like this, but emergence, the idea that data that emerges from the training information. The idea is that there are patterns that we may or may not be aware of that by the automatic training appear and are used in the decision processes, which is something that we need to be very aware of, because those patterns may or may not represent the things that we are interested in, or the things that we care about, or the ethical values that we hold dear. Because we're training an automated process with data, and that data is inferring things that we don't want to perpetuate, for example, racism, then we need to be aware that this emergence happens and it turns into actual this, because they expand the processes that exist. For example, and again, going into this confusing situation, my first idea for the door was to make an homophobic door, not a racist door, but then I got a fellowship and only had 2 weeks to make it, and it was easier to detect race. But that work was inspired by this paper from Stanford, where they found that a predictor of being gay or not performed at better rates than humans. And again, that is not true. It's kind of like a new false measure of men, because but they did learn things that were present in data, and one thing is that in the training data, gay men tend to be more neatly presented than straight men. So what they learned was to classify people that pay attention on the way they looked within certain beauty standards, right? But there is a correlation in the training data between being neatly dressed and being gay or straight. This of course, this paper generated a lot of reaction, and it's very interesting because it really looked like the measure of man, like this idea of that we can, the phrenology, right? That we can predict a certain cognitive characteristic from an external appearance, which again is we need as practitioners and as people that navigate this confusing world, we need to be aware of the worldview, the understanding that these technologies or the social use of these technologies put forward. I want to skip this. And other examples of things, you can predict wealth from space. You can predict how much money on average a certain neighborhood has just by training with examples. If they look at how many swimming pools are there, or for example, they look at how many baseball stadiums are there. If there are a lot of baseball stadiums, then people are poorer. If there are no baseball stadiums, then people tend to be more wealthy, which is something that they figured out because the neural network highlighted that, found that pattern, and it was like people did not know that before doing that training. There is also they can predict, if this is all in the US, they can predict if a certain block is going to be majority Democrat or Republican with like 90% of accuracy, just by taking photos of the cars that are parked, which again seems to be extremely, to me it's mind-blowing. It's something that I would not think, especially in places in the US where every single bloody person has a car, and yet there is a strong correlation not between the price of the car and the political convictions, but between the models of the car. If you favor certain cars, therefore it's most likely that you're going to vote for certain things in a completely unpredictable way unless you train with the data. So to finish, I'm going to go back to this idea to this preoccupation between democracy that I was mentioning or hinting at the beginning of the talk. And one of the things we said, all right, we need data. data to train things, data to be able to predict things. And by trying to create more data, we've invented techniques to create fake data. And that actually has had and is having a strong impact on democracy. For example, by generating fake data that can swerve the social conviction on a certain aspects. For example, there was a vote on net neutrality in the US in 2017, and they used the same techniques to generate fake support, because they had like this in the US. They had this online service that you can voice your support for a certain decision. So they used the same techniques to generate hundreds and thousands of millions of fake supporting for a law that ended up passing. And they used a combination of fake names and existing names, and they took names from people who have died. For example, the grandmother of somebody called Mackenzie Astin. I was very interested in this, and I still am. So I have a few slides of that. And here we have the number of fake comments used with stolen identities in the US with this net neutrality poll by state. There is I highly recommend that you take a look at that link, because there is the results of the study. But they found that they used 1.3 million fake comments, and then they studied how those comments were generated, and they're generated with the same techniques of training and then generating data. And this takes me to the point of, and this is the new electricity thing. This is what changes. There seems to be no fundamental limits of what can be achieved by the same idea of training with existing data. The things that we thought were intrinsically away from the realm of things that can be done with computers, now we kind of like think that they may not be true. This will have and is having impact on a lot of things. For example, the simplification of structural inequalities, the liberation of attention, which is something I'm fascinated with. A lot of things require a human paying attention. Driving is the key example. Driving is a computationally complex problem, but not a cognitive complex one. Every idiot drives around. But they require you to pay attention. If we can delegate that, then it liberates the attention, which has a potential enormous social impact. For example, you don't need to have restaurants at the side of the roads anymore, because you don't need to stop for fooding. Verbing words language. So that will perhaps make all this industry of people providing with food obsolete. Or you don't need love hotels anymore. If you can have sex in your car, you don't need to stop and go to have sex somewhere. Then there's a whole industry that also seems not to be relevant anymore. Or perhaps we're going to start pairing things, so you don't go to the gym anymore because you have 1 hour commute because you live in Hong Kong. So you take, instead of taking a taxi or the MTR, you take a gym car that takes you, and you just do your thing in the car because you don't need to pay attention anymore. That also has a weird impact, which is attention now becomes a posh thing, a thing for rich. If you apply to a university in the US, and it's a cheap university, it's a massive university, your application is going to be processed by a neural network. And you're going to be accepted or not accepted into this university depending on the results of that. However, if you apply to a very, very, very posh, very, very exclusive university, your application is going to be processed by a person. So even though these automated processes are touted as the great equalizers, oh no, we're all the same, we are processed in an automated way, bloody hell, no, if you can afford it, you're gonna be given the right of a personal attention and so on. this possibility of generating believable things opens doors to incredibly weird things. For example, there is a social consensus that child pornography is wrong. Everybody thinks that. Is it wrong to have a computer generate child pornography that is extremely believable with no children involved? Because you train it with a porn film and then with photos of children going to school. Is it right? Is it wrong? Should that be legal with no person involved? Should that be frowned upon because it's weird as hell? I don't know, but these are the questions that we need to answer. I've been wanting to create an artwork that generates child pornography and does not show it to anyone. So it's just a computer, and you're gonna see just a computer, and you know that it's doing that inside. And I'm kind of like too scared to do it, especially because I have to train the data, and I don't want to see myself. I don't want to put myself in a situation where I need to see if that's working all right or not. And there's another thing that is already happening, which is what is called designing for the algorithm. Because we know that there are automated processes, then we change the way that we behave, or we change the way that we generate data in order to fall within the prescribed behavior of the automated process, which is something that in theory we wanted to do exactly the opposite. We wanted to have algorithms that would react to our humanness, and now we have the algorithm put and we adapt our humanness to comply with the prescribed behavior of those algorithms. There's another link here that I give you to take a look later. As I said, this I'm going to put this online, this slide. There are other things. Stephen Hawking, before dying, discussed this quite a bit. And one thing that is very interesting is that machine owners successfully lobby against wealth redistribution. So we would also need to think, okay, having access to data and to computing power to train your own models should be a human right, something that everybody should have access to, so as to escape the prescribed things. I cut these two things out from the talk because I was going to talk forever. But the impact in privacy and ownership are insane. Now we have systems that can measure your bio data from behind the wall, thanks to how your body changes the strength of Wi-Fi signals. So I can tell if your blood pressure or your heart rate from behind the wall just by looking at my Wi-Fi router, which is this idea, this notion that we had that there are private spaces that we can escape from the scrutiny of the people who own the computing power. Forget it. There's no way to hide. And as I was mentioning, the impact on social everyday behavior or activities is going to be absolutely insane. So to finish, there are three ideas. AI will change, or machine learning will change everything, while not changing anything, while keeping in place the social structures that we operate with now. There is no I in AI. This is machine learning. It is what we talk about. There is no intelligence in the human sense of the world. And there is an urgent need for a social and legal updating in order to try to go to a better world. So I like this image, which is something that if there were an AI in AI was more likely to happen. And thanks.
Okay, questions?
Or answers.
Responses? No questions?
Oh,
okay. Yeah.
Hi, thanks, Professor. Thanks for the talk. So my question is, so to date, all the data, always came from the past. And how we train the machines is also we impose, as a human, we impose the values to the machine, to the AI, how we use the AI based on our values, right? So can I ask your point of view is when and what if AI or machine have their own values? And from your point of view, what it is? Because people keep asking, our job will be replaced by AI soon, right? Then the next question for us to ask ourselves is, how can we contribute values to AI? I don't know what it is, because except reselling our DNA or kidneys, what can we be useful?
But this is, well, those are the questions I'm raising, those exact questions I'm raising with the talk, which is, we don't have, AI, as far as we can predict in the future, will not have values in the sense that it will not be sentient being. However, they do have values in the sense that they do have agency. They do perform activities in the world. The ways that we have to steer that activity is through training data. So by paying attention on the data that we use to train and generate that behavior.
Because at the moment, there are always someone at the back to decide what values it is.
No, they're not.
But I can understand. Say you have two institutions. One is from Tencent from China or Google's from the America. You should have two different set of values. For example, your example, selfless. What's that called? The self-driving cars, right? When the cars see the trolley problems, a car from China would have a different solution from a car from America, right?
Yes, but as I said, I don't know if I don't think I understand your question. If the question is how do we,
because the values of the AI or the machine choose to adopt.
Yeah.
At the moment, it's still decided by human.
Okay, but what you're saying is a bullet inside a gun that is on the hand of an American person will have different values than the bullet that is inside the gun of a Chinese person.
Yeah.
Yeah, but what I answer to that is I don't think bullets have values. I think bullets are little pieces of metal.
But so is AI. But
yeah, exactly.
But the thing is, AI would be intelligent enough to create their own values. That's my question.
But what do you mean by your own values? Doesn't Apple embodies the understanding of
different purposes, or they don't have to generate fake porn or something. They can create some other products. I don't know what it is. So that's why I'm asking you. What do you
what
think
I'm saying is, in the foreseeable future, that is not a concern. The concern lays on the social structures that allow for the use. It's more like it makes more sense to think of the neural network of the AI as being related to the bullet or to the gun than to be related to the person making the decision. That's why I was saying that was what I meant by there's no I in AI, and that's the situation we are and the situation we're gonna be for a long time.
Okay. Well, I feel it's more transient. There's just a middle step at some point. Then they generate their own values. Then what it is, because our job will be replaced by AI. Then how can we?
But that was my point. Our jobs are gonna be replaced by the AI. But it's the same. Would be in the same situation that we're not. That we have the technology, we have the knowledge, we have the infrastructure to have cars that don't pollute. Yet, 99.9% of the cars, actually 100% of the cars we use are horrible for the environment. The decision there is not technological. It follows other. It's a political thing. It's a social thing.
I don't know if I understand his question from a different point of view. Maybe are you actually asking questions such as whether or not we want to track down whether a face is white, brown, or yellow? It starts with a human decision, because I decide to track, racial differences, and therefore, everything else came after that. So it's a human value. Is that somehow
something like that? Because Because when we have a job, we have a values. We create some values for someone, right?
Yeah, that value is called capitalism.
But then, if the AI is so dominant on all kind of industry, then what is our values?
Exactly. Well, the same. What you're saying is there's going to be a technological advance that will allow us, for example, not to engage in manual labor anymore, or in certain kinds of cognitive labor. Therefore, and that's your assumption, that is going to have an impact on the world that is going to change this and that. What I'm telling you is that probably will not be true, because even though we have the technology, we don't. The decisions are social, are not technological. We have the money, the resources, so to have people not be hungry in the world. There is more food than people, yet there is 50% of the world population under the poverty line. That is not. Why do you think things are going to change with that specific technology and have not been changing with any other technology for the last 200 years?
I think that probably is the point that it's different between me and your perspective, because you still have the human factors in your answers, right? But what I'm trying to think of is, if the technology is too advanced, they don't need to care about the people who is starving.
Yeah, but you know, just go unemploy them.
Huh?
They're going to have power sockets. You know, the robot uprising is something that...
No, it's not the robot uprising, it's just that the economies don't have to care about people who is starving.
But that's the situation we are now. You see, the main shaping forces in the world are the big corporations. The big corporations don't care about mankind. Look at the result, look at the environmental impact, look at the social impact, look at the economic impact. This situation you're describing is the situation we're in.
Perhaps we can come back.
Yeah, I should come back.
Yes. Okay, over there.
It was Felipe before.
Diogo, coming.
Thank you. I wanted, to also participate in this conversation and to open it more to more people. And then for me, there is a certain, not really scared, but suspicion. And when we talk about social, because, for example, when we see social media and we see the actual, resources that are taken from social media, they are not improving social structures, or they are not really caring about social people. They are targeting individual choices to make more money. So when we are now putting social in AI, I'm a little bit worried that it's the same thing. It's just one more word to make more money. So I'm a little bit worried about this uprising of AI. Yeah. But then most of it is statistics more than machine learning even.
I am very worried, but not about the Robocop. I'm very worried about capitalism, or whatever the new version of capitalism is going to come in the near future. There's also something that I did not touch in the talk that I'm very interested in, which is the human labor components of machine learning, which is, okay, from what I said, it looks like it's a very clean process, and it's not. It requires a lot of human labor that is complicit, but also generates its bias and so on and so forth. The social credit in China is vastly automated, yet it needs people that are in place, that recollecting data, feeding the data, and put it into the computer and so on and so forth. And that is a very, very relevant part of the whole machinery that it's not being addressed in the narrative so far, and of course not in my talk.
Thank you. I would like to ask a question on, because you are an artist and a computer scientist, am I right? You care about how data are being represented. And for me, my understanding is that we are developing machines that act more like human. There's a trend. And on the other hand, just like Microsoft have principle or guidelines saying that we should design machines that act functionally, responsibly. And on the other hand, they say, the Microsoft engineering says, we should make the machines, let the users know that it is a machine, not a human. So it is a paradox. We are designing machines that act like human, we think that is human, but on the other hand, we have to know it is not a human. So this is a paradox, and I want to know your stance or how you make a balance between them. Thank you.
I don't, and I agree. It is a confusing situation we're in, but the main forces are forces I don't agree with. So I don't really care if the sources of oppression are more or less automated. What I care about are the forces of oppression. Again, I think that the discussion about the social impact of AI is very relevant because it's going to be enormous, but I don't think it's going to change the social structures that are in place that are quite horrible, in my opinion.
It actually enhances them.
Oh yeah. Well no, there, yes and no. There are a lot of awesome things. There are like healthcare is a clear example. Now we can classify images being cancer or not cancer with hundreds of times more accuracy than before. Yet that has had zero impact on the number of people having access to healthcare.
Next question.
Not necessary.
Over there.
I wonder if you could reflect on, I think you're right that there's an important shift from explicit to implicit modeling, although coders have always used data, so I thought it was a little bit simplistic, the distinction you made. But sort of the pedagogical ramifications, since we're in a teaching institution, from the case where you need to understand something in order to work with it, to this new model where that understanding is not required.
I didn't answer the question. I agree.
Pedagogical implications of not having to understand a problem to solve it.
Oh. Let's talk on Tuesday. No, I don't know. I would repeat what I said before, that I think the forces. I think educational institutions are very schizophrenic. They are tools to give knowledge to people, while at the same time they're tools to propagate social structures and to create people that fall within those social structures. So I would repeat what I was saying before. I think that the main discussion will be in other places. In terms of teaching computer science, that's a tricky place, because the border of how much you need to understand in order to be an efficient cognitive worker is very hard. And
I'll make it even more specific, right? We teach, how to make creative things with computers, right? So if we look at two paradigms, on the one hand we have Harold Cohen, who used a heuristic explicit model for how to create paintings with code, right? Visual representations with code. In the new model, we just feed in a bunch of examples, right? So how does that change what you or what we do as a teacher when we now say to a student, we're going to do work today on understanding painting, but we don't need to know anything about painting?
Well, I thanks for rephrasing the question, because I have a sort of an answer. And I think that new art, or the things that we do, is in a way the art of the explicit. It's the art that appears when a certain processes or concepts or ideas are made explicit and therefore can be used in the construction of a new artistic language. So, quoting your advisor, your PhD advisor, Ken Pelling, he said that oil painters were using a controlled random process centuries before John Cage made such a fuss about it. And that is true. A paintbrush is a controlled random process. You don't have control of every single hair of the brush, but you control the overall statistic behavior of the paintbrush. However, things that incorporate randomness, like John Cage, in an explicit way, allow for the creation of an artistic language from that. So I think that in terms of this, the same thing is going to be with computer science. And that's what I was saying, appropriating the processes for creation, for creating new knowledge. I don't know what the cool, interesting, relevant, valuable art in the age of artificial intelligence is going to be, but I do know it's not going to be, okay, I'm going to train with this bunch of examples and then this thing is going to generate whatever. It's going to be something that is going to be, that's going to appear by the effect of these two forces, the forces of appropriating the processes of creating knowledge and making explicit things that are implicit, for example, in this example of training and just generating things.
Yeah, I wanted actually to give an answer to your question. And it's partly Tomas had just added to it. But I think that the expressions explicit modeling and implicit modeling come to the point of, so in the past, we only talked explicit modeling. So we had some paradigm, we tried to understand it, and then in the measure that we were progressing in the understanding of this paradigm, we would explain it. Now the paradigm is a sort of meta paradigm. We have one, and then we have something that understands this paradigm only implicitly. But then we need to explain that. So pedagogically, it seems that what we are going to do is to transmit the knowledge of how to implicitly model a paradigm. So we have new pedagogical needs in a way. But we have an explicit modeling for that implicit modeling. Sorry for the...
You're talking about the architecture of the model rather than the content of the model?
Exactly. The architecture and the way it works. So Tomas somehow just skipped the issue and then just said gradient descent and backpropagation, and then quickly passed to another slide. But these things remain to be understood, and there is some understanding of them, of those things, and is that what we eventually will end up teaching?
Yeah, exactly. This is the shift that I see is when you work at this level, you start talking about things like number of hidden layers and softmax and gradient descent versus whatever other optimization you want to use, rather than the formalization of the kind of things you wanted to that you talked about in your talk. Right? We don't need to understand perspective if we can recognize and generate any. That's the question, right? Or what do you say to the student who says, "Yes, you're teaching me algebra. That's very nice, but I can write this model that can solve any problem without understanding that much faster than the methods you're teaching me."
You can't write a model.
That would be nice, but in the particular case of algebra, thanks God, that's impossible.
Yes, maybe algebra is not the best
Improve
case,
that.
but there's certainly cases that you can imagine.
Yeah.
More, yes, over here.
Thank you. So basically, if we see in very big, like as you can say before, like a lot of AI can help like humankind, but AI also about like big data, right? And then like there must be like someone also misuse like big data and then like maybe create something else. And then do you think it's important for law to take part in AI in the future?
100% yes.
Okay, follow up or another part? So you are basically inviting all of us to think more and into the specificities that this new world is opening up. I know you don't like the word new, but for those of us who are not programmers, what are some of the things we can do? And let me know if this is a rational question or not.
Well, no,
I think
it
there's
is,
a lot
it
to
is
think
very
about.
rational, and it ties very well with what Hector and Daniel Felipe and Daniel were discussing, which is what level of technical knowledge is required in order to have an informed discourse. And I, for those of you or of us that are not programmers, I think there is a necessary, unavoidable need of getting some technical knowledge, that it cannot have an informed opinion by taking, if you take the whole area as a complete black box. But I really do not think that you need to be an expert in order to contribute. I don't know how a car's motor work. I know there is something that explodes on the pistons or whatever, but I don't really know. Something that I've been meaning to learn for the last 40 years. Well, no, 38 years. And yet I think I have an informed, reasonable opinion on the impact of cars in cities and in the world. So there is of course, if cars were like magic beasts that propel on magic, probably my opinion would not be relevant. What is the good thing is that, given that we are all in a university now, in a very expensive city and conversing in English, probably we all have access to sources of information that can help building that narrative or that informed opinion.
I can certainly relate to that in terms, even on the level of pedagogy or curriculum design for future. Any more? If not, then maybe we should, let the lecture ends with a big applause and then more questions.
Three dark shadows on the